Hello, so if you can turn to page 27 from your logs packet, from your Unit 6 packet, what we're going to talk about today is the doubling formula. And you'll see at the top of the page here, the formula is given to us. Okay, and we're pretty familiar with most of these, what most of these components mean. A is the amount remaining after, T time has passed. P is the initial amount. Actually, this we don't really need. I'm going to cross that off. This is what we're going to need for the next page. So I'm going to cross that off. I mean, technically you need it for the next formula, so you can leave it if you want. D stands for the doubling time period. Okay, so see how there's a D in there? It's the amount of time it takes for whatever the substance is to double. And then T, I'm going to just add this down here. T stands for the time that has passed. So you guys can put time down here. All right, so let's take a look at number 64. It says a wolf population doubles every 2 weeks. I'm just going to underline that, okay? So it doubles every 2 weeks. There are currently 6 wolves, so that's how many there currently are, in a restricted area. If T represents the time in weeks, and P of T is the population of wolves with respect to time, approximately how many wolves will there be in 70 days? Okay, so I can tell I'm going to be using, the doubling formula because of this right here. It says that the wolf population doubles every 2 weeks, okay? So basically when something doubles, it's growing by 100%. So normally within our parentheses, right? Normally, don't we have a 1 plus R in the parentheses? And let's think about it. If something's growing by 100%, let me write it like this first. Wouldn't we take the decimal and move it back twice so it becomes 1.00? So if I take 1.00 and replace it for this R, isn't 1 plus 1 just 2? So that's really where they're getting that from. But if you remember, if something doubles, you put a 2 in there. If something triples, you put a 3 in there. It should be easy enough. All right, so let's take a look. So using this formula, they want us to figure out if we start with 6 wolves and they double every 2 weeks, how many will there be in 70 days? So we're looking for the A, the amount remaining after time T. So I'm going to leave this as an A. And if you weren't sure, you could just plug in everything you know and just see what variable you're left with. All right, now P stands for the initial amount, which we know there are currently 6 wolves. That's how many we're starting with. So I'm going to replace the P with a 6. And then in parentheses, we have a 2. All right, and that's going to be to the T over D power. Now, T is the time that has passed, and D is the amount of time it takes for something to double. Now, it says here it doubles every 2 weeks. So I'm going to replace that D with a 2, okay? It takes 2 weeks to double. So the denominator is going to be a 2. Now, in the numerator, it's the time that has passed. And keep in mind, it says T is time in weeks. Now, if we look here, they give us 70 days. So we're going to need to convert that to weeks. I'm going to do that off to the side. So 70 days. Well, since there's 7 days in a week, if we take this and divide it by 7, that'll give us 10. That means that 10 weeks have passed within 70 days. So in the formula, I'm going to replace this, not with a 70, but with a 10. Because if the denominator is in weeks, we want the numerator to be in weeks as well. Okay, so let's replace that with a 10. Okay, so now really all you have to do is just plug this into your calculator. 6 times 2 to the, you could either type in 10 divided by 2 power, or isn't 10 divided by 2 just 5? So you could plug in 6 times 2 to the 5th power. Okay, and when you do, you wind up getting exactly 192. So 192 wolves. Okay, so just to quickly go over that again, the initial amount was 6, so we put that in for the P. We know that it doubles every 2 weeks, so I replaced the doubling time period with a 2. And since that was in weeks, I had to replace the time that has passed with what, this is equivalent to in weeks. So 70 days, if we divide 70 by 7, because there's 7 days in a week, it gives us 10 weeks. So I replace that with a 10, and then we just plug it in our calculator. Okay, number 65 is very similar. So I'd like you to hit pause, try that out on your own, and then you can check your work with mine. Okay, so I'm going to go through it. So it says a rabbit population doubles every 4 weeks. Okay, so it doubles every 4 weeks. So now that we know how the formula works, I know that that 4 is what I'm going to plug in for the D. Okay, so I'm going to replace, let me just erase as I go. See if I can do it like that. I'm going to replace this D with a 4. And I'll do it in different colors. That way we can see what's going on as I go. So there's a 4. Okay. Now it says there are currently 5 rabbits. So that's the initial amount of rabbits we're starting with. So the initial is P. So I'm going to replace that P with a 5. Okay. Then it says if T represents the time in weeks and P of T is the population of rabbits with respect to time, about how many rabbits will there be in 98 days? Okay, this is in terms of days. And remember, we were doing time in terms of weeks. So if we want to convert from days to weeks, well, let's take 98 days and divide it by the number of days in a week. And when we do, what does that give us, 14? Yeah, that gives us 14. Okay, so the time that has passed, okay, this is representing the time that has passed. I'm going to replace that in the formula with 14. All right, so it looks like we have numbers for everything on the right-hand side of the equation. So we could just plug this in our calculator. You could type in 5 times 2 to the 14 divided by 4 power, okay? And then when you do, you wind up getting, well, you're going to have to round here. I'm just going to write out approximately, I'm just going to say for right now, 56.6. Now, we know we can't have a decimal of a rabbit, and that's why they use the word about. Okay, they just want to know, out of these answer choices, which is the closest to this answer right here. So it's choice 1, 56. All right, if you could flip to the next page, page 28, there's 2 examples on this page that we're going to try. Now, what I'd like you to do is read number 66, and we can tell again we're using the doubling formula because I see this word double right here. And I'd like you just to plug in the numbers where they go into the formula, and then you can hit play and see how you did. Okay, so this is what I did. A person invested $940, so that's the initial amount. So I replaced the P with 940. Okay, it's growing at a rate that allows the money to double every 8 years. So 8 is the doubling period, so I replaced the D. Oop, that's supposed to be an 8, not a 2. There we go. Don't mind my handwriting. There we go. Okay, how long to the nearest tenth of a year? I'm gonna kind of underline that because we're gonna need that later. Would it take for the value of the account to reach $3,500? So this is the ending amount. Okay, that's the amount after a certain number of years of passed. So I replaced that for the A. So we're looking for, it says how long. We're looking for T, the time. Okay, so this is what we have to solve. Now, if you could again hit pause, try this on your own, and see what you could do without my help. And then you could hit play and see how you did. Okay, well, I'm looking at this here, and since we're solving for an exponent, right, we need to get this base of 2 that contains the exponent on it all by itself, okay? So I'm going to first get rid of the number in front. And keep in mind, you are not allowed to multiply 940 times 2, because this isn't just a 2. This is a 2 to some power, okay? And remember, think about way back when PEMDAS, exponents come before multiplication, okay? So we're not allowed to multiply these. So let's get rid of the 940. We can divide both sides of the equation by 940. Okay, so on the right-hand side of the equation, we're left with, you could keep that in parentheses or you don't have to, it's up to you. I'm gonna actually take it out. 2 to the T over 8 power. Okay, and then on the left-hand side of the equation, if you try to divide these, it gives you like a big, long, ugly decimal, right? So in your calculator, if you hit math, enter, enter, let's see, it simplifies to 175 over 47. Okay, I wouldn't write the decimal though, because, I mean, if you can avoid rounding on your paper, you want to, but if you have to, you have to. Okay, so now, if you remember, in order to solve for a variable that's in the exponent spot, if we put the word log in front of both sides of the equation, do you remember that allows us to take the exponent and bring it in front of the word log, so we no longer have the variable as an exponent? Okay, so we're going to be left with log of 175 over 47 equals T over 8. Okay, I'm bringing that to the front, times log of 2. All right, so we're trying to solve for this T here. So I want to get rid of, first, the log of 2, right? So if we just divide both sides of the equation by log of 2, we can get rid of that altogether. Okay, so then on the right-hand side of the equation, I'm left with t over 8. Now on the left-hand side, if you plug this into your calculator, even if you hit math enter, it's still going to give you a big, long, ugly decimal, okay? You can't change it into a fraction. So what I'm going to do is I'm just going to round to 4 decimal places on my paper, but in my calculator, I'm going to keep that entire number on my calculator screen because I want to, I want my calculator to keep using that entire number, not the rounded version of it. All right, we're actually almost done. If the right-hand side of the equation is a fraction, I can make the left-hand side into a fraction by putting it over 1, and let's just cross multiply. T times 1 is t, and then the top left times the bottom right rounds to, I'm just going to put it to 4 decimal places on my paper, and actually that 299 is going to round to a 30. So we want to know to the nearest tenth of a year, how long will it take for his account to reach $3,500? Well, to the nearest tenth, right, we're going to have to round this up to a 2, so it's going to be 15.2 years. Okay, and then finally, I'd like you to take a look at number 67. And again, I mean, I'd like you to try this on your own and see what you can do, and then you can hit play and check out your work, see if you got it right. All right, so this one, they gave us a formula within the question, and we know it's the doubling formula because there's a 2 being raised to the power. Even though the 2's on the even though the t is on an exponent on the inside of the parentheses, aren't you allowed to move that to the outside if you want and have 2 close parentheses to the t power? It means the same thing. So this is the doubling formula. So it looks like we're starting off with 100, which they told us. Okay, we have a starting population of 100. And it does say if each period is 15 minutes long, how many minutes will it take for the population of bacteria to reach 51,200? Now, this might be a little confusing to you, but let's just take the formula they give us. Okay, T stands for the periods of time. How many time periods we're going to have. We don't know that. Okay, we need to find that. We want to know how long is it going to take for them to reach 51,200. So I'm going to plug in 51,200 for the left side of the equation. That's going to be the ending amount. And we're going to solve for the number of time periods that have passed. Okay, so we solved this kind of the same way we did the last one. We're going to first divide by 100 because we're trying to get the term, the base that has the variable exponent on it by itself. All right, so now that would leave me with 512, that divides evenly, equals 2 to the t. And since our exponent is where the variable is, we're going to need to use logs to solve. So I'm going to put the word log in front of both sides of the equation. That way I can take my exponent and bring it to the front of the word log. So I'm left with log of 512 equals t times log of 2. All right, and then when we divide both sides of the equation by log of 2, because we're trying to get the t by itself, that leaves us with t equals, and you could plug this into your calculator, and you wind up getting 9. Now, t stands for the time, the periods of time. So how many time periods have passed? This means 9 time periods have passed. And now they're telling us that each time period is 15 minutes long. So if we want to know how many minutes have passed, we could take the number of time periods and multiply it by how many minutes are in each time period, and that will give us the total number of minutes that have passed, so 135 minutes.